Hi, welcome everyone. This is Israr Ahmed. This presentation is about Assignment 2 for the Big Data Analytics. I'm a student of PhD in the British University in Dubai. So in this connection, I have this presentation for my Assignment 2. So here we have the topic Desire of a Novel Classifier Using Random Tree and Bagging Techniques. This presentation is about a paper that is based on human activity recognition, a popular data set. So we will be discussing different topics that are here. The first thing is introduction. That will be I will be introducing some basic points about our data set. Then we have the literature review, how we define this problem. Then a little discussion about the activity recognition framework, justification. Then we have the experiment setup, performance criteria, how we perform the tests here, and then I will be discussing results, and finally the conclusion. So here is the introduction. Electronic devices are becoming the requirement for all professions. Human activity is a challenging task. The human activities are identified using the data collected from a smartphone. Here in this work, we explore human activity recognition as a classifying problem. Each motion characterized by sensor data from a smartphone is categorized using a preset of activities. The report critically review the existing solutions for human activity recognition problem and highlight their limitations. Smartphones are playing an important role in our daily life. Working with electronic devices is becoming the requirement of all professions. With these devices, many experiments were made to improve the quality of life. HAR is a field committed to observe the daily activities of people by means of computational techniques. Different classification techniques like ambient assisted living, hidden Markov model, and so many others have been connected to this theme. They have different degrees of success. Human intervention is needed in many systems for decision making, usually by means of interaction through traditional devices such as keyboard, mouse, switches, touch screens. Human activity recognition has been adopted by many researchers, in which methods for understanding human behavior are acquired by reading characteristics derived from motion, locality, physiological signals, and environmental information. This field is the first element sensing of series for achieving smarter interactive cognitive environments jointly with data analysis, judgment making, and taking actions. And the same is the focus of this research paper. Here in this research, meta-bagging and random tree algorithms are mainly focused and compared based on their performance. Bagging or bootstrap aggregating is a method that generates distinct samples of the training data set and generates a classifier for each sample. The results of these multiple classifiers are then joined together. When each sample of training data set is dissimilar, each classifier that is trained is given a stably different concentration and evolution on the problem. On a large data, bagging might be too computationally concentrated. However, when data is small, bagging is computationally feasible and give performance gains. This paper is structured as follows. We begin with the discussion of our data set, followed by the enduring work performed. This paper is comparing different algorithms for the data set, focusing on two main algorithms, and lastly we present the test results showing the reliability and feasibility of the proposed method. Finally, we conclude an outline of our future work. After the introduction, we have the literature review. Here we surveyed 10 different research papers. They use the same hard data set. So the papers surveyed are grouped as follows. We have unsupervised learning models, the first two papers. From paper 3 till paper 8, they are supervised learning models, and last two research papers they are surveyed is initial sensors application papers. Here is the first surveyed paper with the title Unsupervised Feature Learning for Human Activity Recognition Using Smartphone Sensors. A Chinese researcher, Yang Muli, presents an official learning technique to generalize the human activity recognition mechanism. The author used principal component analysis along with sparse autoencoding based learning methods to adapt to the changes in the activity. To improve the issue of handheld features, they introduced the component origin system, which uses diverse information component learning system to learn valuable figure interpretation from two sensors, accelerometer and gyrometer, for human movement detection. The informal learning system they explored incorporate an educate automatic encoder, demonstrating PCA and autoencoder. They assisted the execution on an open human movement acknowledgement dataset and furthermore contrast the technique and conventional highlights and another method for unsupervised learning. HAR is looking for the sensor information during a particular time period and recording the information based on the motion or action taken by the object. There are three stages or phases taken into the account by HAR: dividing device information streams, extracting highlights, and characterization. The information received through HAR is mostly used in the sliding window strategy, in which recording of data is done with settled time window with certain corresponding breaks to frames. The researches on human activity recognition done by many researchers selected through hand. The handmade highlights depends on specific space learning and ordinarily utilized as a part of HAR. The solution provided for these issues utilizing the learning strategies for anamorous information, which is data adaptive. The outcome demonstrate that the learned highlights of the structure beat the other two strategies. The human activity can have several variations with respect to gyro values of a device. PCA can generalize these variations to classify them into one category like walk, run, etc. The results showed that PCA significantly improves the efficiency of unsupervised steering algorithm of. The second surveyed paper is human activity recognition using smartphone sensors with the two-stage continuous hidden Markov model. The authors in this research paper used a variation of multi-layered networks called convolutional neural networks. The work investigates different layers of conventional neural networks. The outcome demonstrated that expanding the number of conventional layers, the neural system execution is enhanced too. The execution of the work is estimated by utilizing forecast exactness. Time arrangement data has unavoidable neighborhood dependence properties. In addition, exercises tend to be dynamic and translation invariant in nature. In this manner, conventional neural networks misuse these qualities, which make it appropriate in overseeing time course of action sensor data. The author proposed an outline of conventional neural networks with sensor data gathered from mobile phone sensors to see exercises. Analysis shows that growing the quantity of conventional layers assembles execution in any case. The complexity of the decided feature decreases with every additional layer. Also, sparing the information from layer to layer is more basic as opposed to endlessly extending the hyperparameters to upgrade execution. The structure of conventional neural networks can, in like manner, benefit from broader channel amount and lesser size of polling settings. The results show that conventional neural network based learning approach performs better than SVM. Conventional neural networks take benefits of using restructuring features that is dynamic setting for pooling size and filter size. Now we will start with the supervised learning model. The first paper in this category is Deep Convolutional Neural Networks for Human Activity Recognition with Smartphone Sensors. The author used a tight time-bound classifier to categorize the human activities for hard data set. Their work uses the transition activities, for example, transition from running to walking as a category. Since there could be huge set transition activities, their work add additional categories so-called unknown activities for new or exceptional transaction activities. The main intuition behind mapping the transition activities is to refine the rules for identification of actual activity at a given time. Using learning algorithms, the HAR framework design permits accomplishing the acknowledgement of physical exercises by consolidating estimation using sensor attached with body parts. The techniques is made out for 4 useful layers: identifying, report mapping, estimate, and interaction. Using heuristic approach, they propose 2 different execution of the design which contrast in their figure system as they manage advances either by specifically learning them or by reflecting them as obscure activities. They got the output by combining heuristic pairing approach and SVM support vector machine. Heuristic approach filters the change time spans and after the connected as a probabilistic variety of help vector machines to foresee the human action. One of the scenarios include the test part of the hard data set. Other 2 includes live data from human participants using mobile and wearable devices. Using gyroscope of these devices, the data is fed into the model and then model output is reported as correct or incorrect. The algorithm is compared with other variations of SVM and results shows that heuristic based SVM variation performs better than its rival techniques. A variation of conventional neural system is investigated by one international conference for hard data set. The creator investigated diverse layers of neural system to outline input highlights to the yield classes given in hard. The main feature of conventional neural network is their adaptive nature with respect to temporal variations in data. In the paper, they recommended a conventional neural network as program include extractor for considering human activities using mobile phone sensors. The conventional task adequately exploits the impairment, neighborhood dependence of the time plane signals and the absorption moment across out the effect of the little understandings. 2 sensors, accelerometer and gyroscope sensor data were used to gather information from 30 volunteer subjects who performed 6 different activities keeping the smartphone in the pocket. The data gathered from sensors were detached into windows of 128 characteristics with half cover 128 genuine to goodness esteem vector stays for one case of one activity. The outcome demonstrated that lowering pole size, for example 1/2 or 1/3, can give the calculation a chance to take in the mapping in a quicker speed and with the high accuracy. Toward the end, they contrasted the best conventional neural network and other cutting-edge strategies in hard and additionally profound learning. As per the outcomes, conventional neural network beats other cutting-edge information mining strategies as far as working on the dataset. They propose deep neural frameworks to perform capable, convincing, and data-flexible human action acknowledgement using the gyroscope and accelerometer on the smartphone. Channel gauge is furthermore ended up being effective as common adjacent association between bordering sensor reading has more broad time traverse. The result also showed that if algorithm is combined with Fourier transform, where transforms are used to convert the inputs from one space to another, and conventional neural network then generalize based on transformation parameters, the performance of algorithm increases to 95%. Using hidden macro model, C and Ranio explored HAR by utilizing cell phone sensor. HAR was the main focus of their research using multiple sensors. Human activity recognition are primarily activities human beings perform on a everyday basis, like sitting, walking, laying and standing, moving up, down. They proposed an approach by the usage of a random forest variable, measures for characteristics choice, and two-stage hidden Markov model to diagnose human activities. Random forest variable measures unbroken and possibly high associated variable, whilst two-stage hidden Markov model are suitable for the traits of sensory information and the normal hierarchical shape of events. The commonly available domain UCI HAR fact set was treated for all analysis, occurred from a Samsung S2 smartphone were out involving 30 volunteers. The volunteer performed each activity twice as per given instruction. This way they got data set having 561 features from a sliding menu of 128 samples. The value were normalized to a range of 1 and -1. The data set was partitioned as 70% and 30%. RF technique was adopted and processed the average of variable significance scores from every one of the runs. The results showed that two-stage continuous hidden Markov model is an achievable method for common action recognition on smart mobile phones. Continuous hidden Markov model is able to switch time series data and use smaller numbers as values, applying the most applicable approach. The authors claim that random forest is an active technique along with appropriate domain information for looking useful. Participate from a big highlight set. Use of HAR data set to train the machine learning algorithms to detect motion disorder has been presented by different authors, where the author proposed the use of transition duration between two activities as indicator to detect the motion disorders. The authors mention a new task as an outcome of the simple and easy approach to substantial amounts of facts gathered from different sources like wearable sensors, concurrent database, and compact computing devices. They focused mainly on factual word troubles, especially helping those who need immediate help and movement-related action of human sicknesses. According to the authors, the neutralistic environment could be considered a model for testing, but in many situations may not be sufficient to utilize them. The work presents several features, selection techniques, for example, metric-based feature selection to detect motion disorder for classification of an observation if it suffers from Parkinson's disease or not. The candidate solution for classification are K-nearest neighbor (KNN), artificial neural networks (ANN). HAR dataset has been explored by authors for its application in wearable devices. Their aim was to improve a correct and tremendous method for past-time consequences using wearable devices. They assembled signals of gyroscope and accelerometer into a diverse activity image, which permitted deep conventional neural networks to routinely research the ideal facet from the features for recreation identification job. They take into account 3 steps to check and verify the performance of all activities. Step 1 was to generate image from raw signals. In step 2, DCNN was applied to the procedure image and producing probability of all activities, and in step 3 they were checking for a sharp peak in distribution, so the category of activities was confidently established. They applied SVM to categorize uncertain classes. The input was generated from sensor data and DCNN was used as output. They proposed method on three public set using two strategies, DCNN plus and DCNN, and the result has been much outclassed in terms of focus, computational cost, and accuracy. The author used a multi-layered neural network structure to teach the model to classify the motion. Ours explores use of machine learning algorithm to classify motion into different categories to transitory movements, that is postural transitions. Like many hair projects, they use the same wearable devices to get user-related signal report. The authors presented a smartphone-based available human activity recognition procedure for the division of actions, which proceeds into concern the effect of PTs in method completion, postural transitions in method completion. The human activity recognition method used in past ignored evolutions among methods since their incidence is reasonably low and period was regard to other events was smaller. The researcher used HAR to set up a focused feature set for this purpose, which can act as input for machine learning algorithm to generalize. Author used support vector machine to train the classifier to detect transitory movements from the sensor value of the gyroscope of a smartphone. Marco explores the use of HAR dataset to compare the sophistication of different smart devices and exploitation of inertial sensor information to measure motion variations. The author used their hypothesis that smartphone measurement performance can be perfectly used in replacement of different medical equipment. Their work presents a motion model based on a 3 degree of freedom space. The author used custom built app for mobile devices to collect the data for 3 degree of freedom model. The app used Mohani and Madwick filters to normalize the app data into a common format. The results are obtained by using Crossel and Wallace test on the motion data. The results showed that accent sensors are even with the sensor values and accuracy varies with respect to the events. Encompassing ambient assisted living, AAL, the authors aims to make intensive specialized arrangement and administration to help independent living among more senior adults, enhance their personal satisfaction, and lessen the expenses related with well-being and social care. The main focus of the research was to look for safety of seniors. Citizens with less social and physical activities can easily become susceptible to many diseases. All the life activities of these people are disturbed and they can become totally dependent on others to take care of them. So with the growing ratio in the older age, they found out different values regarding 6 different activities of the inactive senior people. The bidirectional display system immorally exploited signal information from the smartphone gyroscope and accelerometer sensors to infer 6 basic activities. They use hybrid of 3 approaches: artificial neural networks, hidden macro model, and support vector machine. There had been a variety of techniques to tackle the activity monitoring problem, ranging from wearable devices, film cameras, and wireless instrument systems. Each activity was carried out for almost 1 minute. They received more than 5,000 samples from 31 volunteers in the age group range of 22 to 79. Results showed that more than 90% of these attempts, the highest precision got was with the SVM-HMM model. This research paper addressed the problem of classification of motion-based human activity. The possible way to solve such problem is to present the human motions by using the motion-based contexts. These solutions are context-aware and can align each motion with a well-defined activity such as walking, running, moving upstairs, etc. The main challenge of context-aware solution is to balance the quality of solution and speed of finding solutions. The traditional classifier takes huge time to converge but generally produce quality solution. In this work, we propose a solution that finds the quality solution in much shorter time as compared to a traditional classifier. Human activity recognition manages the coordination of detecting and reasoning so as to better comprehend individual activities. Research identified with human action acknowledgement has turned out to be significant in unavoidable and versatile computing, observation-based security, setting mindful processing, and surrounding assisting living. Hard research mainly involves the use of different sensing technologies. The most ordinarily utilized sensors are accelerometer and gyroscope. In HAR, utilizing smartphone. Most of the features used are preferred by hand regarding HAR. These handcrafted features may result in shortfall of information as they rely on particular domain knowledge. Activity recognition is a vital innovation in unavoidable processing since it can be connected to many real-life human-driven issues, for example, elder care and healthcare services. Fruitful research has so far concentrated on perceiving basic human exercises. Perceiving complex exercises remains a testing and dynamic section of HAR. Human activity understanding includes action acknowledgement and action pattern discovery. The primary spotlight on exact recognition of human exercise in view of a predefined movement display. Human activity recognition is a capacity to decipher human body, motion, or movement by means of sensor and decide a human action or activity. The greater part of the human everyday task can be streamlined or computerized in the event that they can be perceived through human activity recognition framework. Commonly, HAR framework can be either administrated or unsupervised. An administrated HAR framework requires some earlier preparing with committed data sets, while unsupervised HAR framework is being arranged with an arrangement of rules during development. Human activity recognition is one of the important research areas in computer vision regarding security surveillance, healthcare, medical science, and human computing. The requirement for fast convergence of classifier is required to provide solution in real time. For example, mobile devices has limited resources like CPU and memory and cannot afford to run machine learning solutions for a longer time period. All the more focus is on more speed and better performance of these devices, but still more enhancements are required as desired by most users. Day by day, the need of electronic devices are growing, and particularly mobile devices are more in demand. Therefore, we focus on optimizing the converging time of classifiers without compromising on quality of solution. This section clarifies the activity recognition procedure and portrays the individual classifiers utilized as a part of our system. We utilized VICA machine learning programming for the experiments, and our activity recognition show was worked after a broad number of tests. We applied 16 different algorithms to do a comparative analysis. We choose 7 classifiers with cross-validation for 10 folds. Backing or bootstrap aggregating is a machine learning meta-algorithm that can be used to enhance accuracy and stability of machine learning algorithms for regression and statistical classification. It also helps to hide overfitting and reduce variance. Random tree was introduced by Alde Culture and Liu Bairn. It has many types of binary trees: minimal spanning tree, recursive tree, random forest, Brownian tree, etc. The trees are formed by sophisticated process. Random trees are a collection of tree predictors known as forests. The class label is selected after receiving the highest votes. In regression case, like other machine learning, activity recognition has 2 stages: training and testing. The variable sensors attached to the subject body to measure different attributes has a wide range like accelerometer, GPS, heart monitor, ECG, thermometer, light sensor, etc. There can be different attributes measured like movement, temperature, location, etc. The sensor sends signal to the integration device that can be a smartphone, laptop, or any other embedded system. The communication protocol can be user datagram protocol or transport control protocol, depends upon the security requirement of the dataset. In order to perform experiments, a laptop with Microsoft Windows 8.1 64-bit having 8 GB RAM, 500 GB of hard drive and Intel Core i7 processor is used. Structural and statistical are two approaches used to extract features from time sequence data. Fourier and invalid transforms use numerical features of data in order to extract features. The structural approach focuses on relationship among the concerned data. Statistical or structural method selection is based on the nature of the signal received. The table here is showing that there is a minor difference regarding mean absolute error. The bagging mean error is 3% while random tree is having error as 4%. The root mean squared error for bagging has a value of 0.115, that's 11%, and random tree result is 0.1994, that's 20%. And random tree algorithm. Meta bagging takes 4.15 seconds to build a model, while random tree consumes only 0.13 seconds. Comparing the correctly classified content bagging algorithm performs well and it was 95.43% accurate, and the random tree which is 88% accurate. The table here is showing the algorithm used comparing different values like the time taken by each algorithm and correctly classified content. Random tree and decision tree work almost in a similar manner with one exemption. The decision tree use irregular subset for each split. Decision tree take in decision trees from both numerical and ostensible data. Portrayal of the data as tree has the ideal position, differentiated and distinguishing approaches of being imperative and easy to translate. The main purpose is to make a grouping model that respects the estimation of the reason in light of a couple of information qualities of the example set. Each hub having input trait of an inside hub is equivalent to amount of the edges. The graph here shows that random tree is taking very less time comparing to meta bagging algorithm. Random tree is more efficient and building the model for the data set in less than a second. Here is the final part of this presentation, conclusion. This report narrates that human activity recognition problem and formulate it as classification problem. The problem is presented using motion-based context and each activity is recognized using context awareness approach. A detailed review of existing solution is presented in the report. The commonly used classifier for human activity recognition are explored using the benchmark dataset called HAR. The results show that bagging and random tree outperforms other classifier. In future, we will try to explore a new technique based on a hybrid of bagging and random tree to improve the accuracy of the classifier.